Hi guys, and welcome to another video. In today's video lesson, we're going to be looking at grade 10 maths, algebra, and solving exponential equations part 2. Now part 2 is going to be where we require factorization to solve this particular equation. Now this is an exponential equation because as you can see the instruction here is solve for x, right? So you can see that the x is in the exponent. Right, so hence it's called exponential equations. So we got 2 to the 3x plus 1 plus 2 to the 3x equals to 12. This came out in a November 2016 paper 1. It's actually a grade 11 question. But nowadays, the grade 10s are also doing these types of questions all the time. Okay, so if you have to now look at how do we do this particular question, right? So first of all, we're going to write a separate term. So 2 to the 3x times 2 to the 1 plus 2 to the 3x equals to 12. So as you can see here, you write as separate terms. Which law am I using here? So basically 2 to the 3x plus 1 is like saying x to the m plus n, which is equals to x to the m times x to the n. So you're using this law where if you have common bases and you multiply, you add the indices. So basically every law, you must be able to go backwards and forwards. So that's how you can now write as separate terms. Now, if you look carefully, you got 2 to the 3x and 2 to the 3x. So the only way for me to now isolate the x term here is to remove that as a common factor. Okay, now let's see if we can. Yes, we can remove that 2 to the 3x into 2 to the 1. So what's left over there? 2 to the 1 plus 1. Always check your factorization by products. If you are to multiply 2 to the 3x times 2, you'll end up with 2 to the 1 there. 2 to the 3x times 2 to the 1 is 2 to the 3x plus 1. 2 to the 3x times 1 is 2 to the 3x. So that's now done. Always check your factorization by product. So what you got now? Right, you got 2 to the 3x. Remember, when you're solving equations, what you have to do is isolate your x term, and we've done that. So it's now 2 to the 3x times 2 to the 1 is 2 plus 1 is 3 equals to 12. Right, so now we can divide both sides by 3. So if you divide both sides by 3, you will get 2 to the 3x equals to, remember, divide by 3, so that 3 now, 3 over 3 is 1, right? So 12 over 3 is equals to 4. Now we're almost done here. 2 to the 3x equals to 4. So now can we write 4 with base 2? Yes, we can. 2 to the 3x equals to 2 squared. Remember, 4 equals to 2 squared. 4 equals to, remember, 2 times 2, which is 2 squared, right? Remember, in previous videos, on exponential equations, we require a common base on both sides of the equal to sign. Then the bases fall away and we equate the exponent. So 3x equals to 2. Now solving for x equals to 2 over 3. And that's the solution. Now, you get more intricate examples where you have to use k-factor substitution, and sometimes it becomes a quadratic equation, but you'll look at those examples mainly in grade 11. But this is solving exponential equations and where we require factorization to solve the question. And what factorization that we're using here? Highest common factor. Okay, so we remove the common factor of 2 to the 3x. Go over it a few times and remember to subscribe to my YouTube channel, like my Facebook page, Justin Lazarus Mathematics. And remember, you can watch all videos in order of the work schedule on jlmaths.com, which is absolutely free. And I'll catch you in the next video.